we are discussed right now. So let's see some graphs. So this is a graph where the number of users in 2007. We think the Asia it is growing larger and larger amounts. And near about 38% of world users, internet users is growing. And then after subsequently Europe countries, then North American, Caribbeans and going on. Let's see some other data. So now in the earlier case we have found that 28% of Asia user is using the internet users. So how rapidly it is growing on. So if we think from 2003 to onwards, we know that every year the number of users is growing and growing and growing. So in future it will be more, we have more gadgets, and our system also, our what is called this, houses will be more smart enough and it will grab the information from the system, from our current environment, and that means the users will be lower and lower in future. Some other data, so number of the data we have. If in 2005 we have some 100 EB, in 2012 2800 EB, and 2013 is 8000 EB. And we found that the number of sizes of total data is increasing every day, nearly 2 times. So we can hope that if the number of data is increasing, means we need to have a big amount of data centers. So again, it's nothing but we need a huge amount of energy consumption. Another, I'm giving a simple example of how the Facebook, one of the giant can say social network, it has huge numbers of huge number of data centers, and the popularity is going very higher from 2004 to 1,100 millions. So you can say how much pressure on the environment is happening for our entertainment purpose. In my opinion, it's entertainment purpose. Another that I'm showing, say number of data centers. Data center, we can say we have a data center in our organizations. Small data centers is there, medium scale data centers there, large scale data centers. Large scale data centers, these are only efficient if you can consider their data as consumption. Their PUE, power and users effectiveness is near 1.2, 1.3 maximum. This is a good result. But if we beyond this scenario and see some other private organization, so the result, how the service is giving and how much consumption is happening is very high. This is showing how much new number of servers it is introducing every year with respect another blue line saying how much expansion of the existing data center is happening. So this is also a huge amount data centers growing day by day. So this is the scenario. So these are some information relating to the ICT based equipments, ICT based service systems. Let's see some other information. So this is the whole world scenario, how much carbon emission done by the all users of the whole world. So this result is not only for ICT, but it is only for every emission done by different equipments, from cooking, from vehicles, aviation system, from ICT, from movements, we can say vehicle systems, etc. So a huge amount of China is having 27% good amount than United States, and there is a type, you can say India and Russia. But India is overgrown the Russia, and you can say India is third most the emission done by the world. Now, if this is the scenario of the whole world, but now let's see how rapidly it is showing on. So this is the graph. If we think about the Russia, United States have second largest carbon emission, but if we see whether it's happening, no. These are going, but after that they are trying to reducing their amount. So it's a good initiative from their country. In China, recently they have boomed. 1990 to 2015, their economy growing higher and higher. Then we are finding out India. Actually, the problem is for India is it's a developing country. Okay, whenever some developing country means any country who is developing is measured how much emission done by the country. Okay, if more carbon dioxide emission means that country is developing more. So we can say China is going to develop and we can say due to the data analysis. But India, a huge amount of users are under what is called this PP poverty line. And India's current economy is more higher right now, 7.6 GDP than the China. So in future, the developed country, in future development will be India. So that means we will have a more carbon dioxide emission in future. The advantage is that India is developing, so we need to design a system in such a way that we can cope up with the environment and make a system efficient. Because our system till not, it is not expanded. We expand, but expanding should be in a what is called a systematic way. It's a systematic. That means we can say how much salary I have, I will expand it. If I have less salary, I will less what's called this spend of it. So this is the solution. The problem is that India is threat for the world because the economy is growing and usually it's a problem. So this is a simple scenario I am giving for grabbing the content. Now let's see an example how we can design a mathematical modeling of any network. Mathematical modeling. Say we are saying this is happening, this way if you go through it, so this is the result. This is we are deciding, we manually are deciding, but how can it be possible to make it mathematical way so that our algorithm calculate it and find out the solution. Say this is I'm giving a simple example. Say a loop network. Say switch 1, switch 2, switch 3, switch 5 switches are there. So and switch have, say we can say 3 flows, S1, S2 and S3. So source to destination is S1 to S4, S2 to S5 and S4 to S5. So 3 flows are there. So this is the scenario, and if you want to communicate that there is a source to destination path. Now question is that how to make this network efficient so that it will use less number of resources. Okay, resources may be considered as different things, but here we are considering only how many number of edges it is activating. So if I follow this structure, say going through this line, how many edges we are activating? Say E1, E2, E3, E4, every edges it is activating. That's the problem. But another, this is one path we can follow. Another part is that say we can move from S1 to S4 via E5, or I am showing in second line. Say the same requirement for flow 1, flow 2 and flow 3, but we can take the different path. Say S1 to S4 in the green direction, then S4 to S5 in a big path it is covering, and second one is S2 to S5 in the red direction. There are two paths we have. So for every flow we have 2 paths. So total 3 number flows, we have total 6 paths. Now solution is there. What is the solution? Solution is this one. If I am moving one communication path from S1 to S4 this direction, green direction, and another to this direction, so the same requirement we are getting, but we don't want to use the E2 and E3. That's nothing but we have the advantage. We have the smart enough system, make the resources smartly handle to reduce the one requirement that is in energy. That's the requirement. Okay, now what is the mathematical model? This is a simple example and we can solve it by manually. Mathematical model is this one. Okay, what is that? So ultimately what we want to need, we want to reduce the number of edges. So this is nothing but is a modeling structure, modeling of optimization techniques. Optimization different techniques are there. Here is a integer programming, ILP, integer linear programming techniques, in which there is some objective, the objective will be solved based on some constraint. Okay, so here the objective is nothing but minimization of number of edges for the system. If the number of edges is minimized, that means we are taking less amount of energy. So this one, the data, that is minimization of this one. And the constraint is that, say we have, first one is called path selection constraint. What is that? We have 2 paths. One is called,
I was interrupting you. Your target is to minimize the edges. So that means you are maybe spanning trees. And
not
every nodes are reachable from one point at the spanning. Now the question is that when you reducing the edges, that the possibility number of possible paths are reduced.
okay.
So if suppose you eliminating E2 and E3, now if I consider E5 or E4 is now
E5 or E4, okay.
E4 is now suddenly a high traffic or etc. or maybe not available for the traffic conditions. So then how this?
Okay, so the problem is that traffic
will come.
Okay, the problem is that traffic is nothing, we can say how much capacity of the link. So this is a constraint. So this is a constraint for the last one, bandwidth capacity constraint. So it will give you the path whenever the link can support the extra flow. Link can support the extra demand from a particular flow.
So dynamically the age will be second.
No, the capacity of a, say, I am saying the Ethernet cable, the capacity of a Ethernet cable is fixed, say 1 Mbps. Okay, so whenever say we have a particular, say, if I go through this one, it's 0.99 Mbps. Okay, and if we are adding some extra flow and it increases the 1 point something, it's not possible. Then in this case, it will take some other solution to consider this constraint, the path selection, then S selection.
Even maybe the node that is maybe switch off.
Okay, the node cannot be switched off in my opinion. Here,
Because battery constants, all the other things.
okay, the problem why I'm saying.
Power constants. Maybe shut down.
Okay,
Or maybe due to failure.
Okay, the problem is why I'm saying. Say if I want to the device fully to shut down, okay, that means the system will consider it as a faulty product. That means if a device is not working, that will simply it will activate some links in failure. Okay, whenever we are keeping it say link down, the system will not work. System will not work. It will think that it's a link down means manually it should check the cables. Okay, so it cannot possible to just shut down the device with S channels. We are only considering only the these edges. Okay, another thing I will just later on I will discuss. This is a simple example. Okay, now what is the solution is that first one is called this path selection model. So we have two paths. The path for the first one is the S1 to S4, the green one, and S1 and the upper one. So only one path will be selected because we don't need the two paths to be work. Okay, the first constraint is saying the path selection will be summation of alternative paths. Total summation of alternative this should be one. It means it will only activate only one link, not the both paths. That is the first constraint. Second constraint is saying, now when we go to the third constraint, second one I will discuss later on. Bandwidth capacity constraint means, say a particular edge, it has multiple number of flows, say F1, F2, F3, multiple number of flows. And if this edge is used by the multiple number of flows, so what is the total demand of the summation of the flows? That should be less than equal to the capacity constraint of that edge. They are considering this one. This is the summation. Okay, for all of I means for all of edges, they are coming on the summation of the demand, the 1 to F is nothing but number of flows, and the condition is showing that. Okay, and the second solution is that edge will be activated whenever a flow is going on. Say if someone flowing is say going say E2, for example E2. So that edge will only work whenever any flow will go. If none of the flow is going, then it is going to be disabled. So this is the mathematical modeling and making it is only abbreviations of it. So we are only considering only the edges, but actually it may be some other issues. Say number of edge, number of rate switch, number 3, the line cards. Every switch has the line cards. We can make it in a what is called this sleeping mode. But we cannot possible to make the device into fully switch off. Whenever we make the system is fully switch off, we will wake up it because the system don't have the capability to switch on by the switch itself. Okay, so make it as a sleeping mode or the switch will be working, but a number of edges will be less. I am giving some example. A famous network, a Evelyn network, famous network. It connects different universities in USA. Most of them I forgot the name, and we found that it's a busy network. They are saying it's a busy network. They have definitely they are not fully dependent on the only one edges. They should have some multiple paths. Okay, and they found that average only 10% in full time, only using 10%. 90% is not using, but still the product is running. The product design. So it's a disadvantage, and we are saying it's a huge one. And it is found that whenever it has the highest load, when it has the highest load, and the result is showing maximum 50% highest load. For a cable, maximum 50%, not total cable summation of total length, it is maximum 50%. It's more than of it. So why don't? That's nothing but we need to have a simple program. Algorithm is nothing but a simple program. A simple place it and run it in the system so that it automatically adjusts. This is nothing but intelligence. Okay, so this is here algorithm we are only considering the edges. Some other I now question is that what are the just notations are there. Just simply I've written some explanation of this notation. This age underscore age suffix I pass these are all decision variables. Okay, these variables are 1 or 2, 1 to 0. It means whether it is activating or not. Which path it is selecting. So flow number 1 has 5 paths, for example. So out of 5, only 1 will be activated. So they are selecting out which path will be activated. That value representing which path and age will be representing which age will be on. So this is a small description of our proposed structure. These are some references. Okay, we have actually the technique in the earlier. If you go through the 2010, the system which I say in our NIT, every networks, every this Ethernet we have are working, but still we don't want to think of it. Let me give you one example. A Ethernet cable have 100 Mbps speed. Yes, 100 Mbps speed, and a Ethernet cable of say 1 Mbps speed. There is a difference of 1.5 watt. 1.5 of just one cable. How many cables you have? Say 1000 cable. So 1000 watt means 1 kilowatt. 1 kilowatt, if we can save it, just simple program. Is it not? So the amount is very slow. Now it says NIT, but some organizations they don't want to compromise. Okay, if you think about the whole world, then it's a good one. I am giving another example. Say now the ICT equipped energy consumption. ICT means the communication, this wireless communication, wired communication, then the desktops, printer, anything. Total is 2% world emission. 2% is huge one. Total emission for different what is called this requirements is 100. Out of 100 is 2%, and that 2% is equivalent to the total aviation of the world. Total aviation consumption is equivalent to what is called this 2%. Give me another example. How much